Good morning. Welcome to Gruber Power Services Power Hour. My name is Claude Dixon, and this is not Elvis Venture. This is Lenny Hodges. Elvis got attacked by a virus yesterday, and he got real sick, and he's at home right now resting. I don't know if he's watching this podcast or not. I told him he didn't have to because of the two ugly guys that are on it, but if he chooses to, good for him. Elvis, we hope you get better. Hope to see you on Monday, healthy and strong, ready to go. To my right here is Lenny Hodges. You've seen him before. Lenny was our senior module repair technician. He has recently been promoted to our three-phase UPS technician. He still is involved with module repair. He's grooming our next guy out there, a guy by the name of Daniel Garcia, who is under Lenny's wing. And Lenny's doing a phenomenal job out there, and congratulations on your promotion.
Thank you. I appreciate it. And Daniel needs all the help he can get from me. No.
Yeah. Well deserved, though. Well deserved, though. The other thing I wanted to just point out real quick is the backdrop. Kind of strange, isn't it? Yeah, you see a big robot sitting back there looking at you at your television. But this was, I'm not going to tell you what it is. I'm going to see if over the course of the show somebody can figure out what it is. I'll give you a hint, though. This was a television series back in the 80s. So I'll just leave it at that, something that I used to watch all the time. Our topic today is capacitors, and these particular beings that you see in the on the thumbnail were powered by capacitors. So that's the whole reason why I chose this thumbnail. Just a little bit of trivia there. We already got something coming in here. To infinity and beyond. Let the show begin. Gruber Power Hour is live. I love it. Hello from Alexandria, Egypt. Ooh, that's pretty cool, huh?
Yeah, it actually is.
All right, so last week, just to give you a review real quick, last week we did capacitors part 1. There's a lot to this, and what we discussed was the different types of capacitors. We went over that in detail, and we also talked about the specifications and measurement values of capacitors in terms of their performance, in terms of, you know, if you're going to quote a job, knowing what to look for in terms of the part number, understanding what it means. An example would be microfarads, what that means, you know, in terms of the rating of the capacitor, what to look for, and the differences between an AC and a DC, positive, negative, those types of things. But today we're going to transition to the key materials. We're kind of like taking it step by step. You know, didn't want to just give you an overall on what the capacitor does, but wanted to go into a little bit more detail on what it is, because there is actually a lot to this electrolytic capacitor and these AC capacitors that you see in this bank here in front of you. And Lenny's going to help me out with that piece of it, the more technical aspects of what we're talking about here. So let's start with the key materials of an AC capacitor. AC stands for alternating current. And the dielectric, believe it or not, we're going to start off with something very fascinating. The dielectric is the internal fluid inside of the capacitor. And right now we're talking about AC, which AC stands for alternating current. And I had Lenny actually open one of these up, and you can see it. Make sure they, hold it up there. And I have my gloves on, so I'm going to go ahead and take this out real quick.
And Lenny, can you pull that mic up to you a little bit? Thank you.
Yeah, so I had Lenny cut it open so you could kind of like see this is an AC capacitor, and we were kind of surprised when he brought this to me because there was a fluid inside of it. And again, they make these without fluid, but we were surprised that this one had fluid. And, you know, the first thing when Lenny brought this to me, he had gloves on from a PPE standpoint. But after further researching this, the liquid or fluid that's inside of the AC cap is not the same fluid or chemical that's inside of the DC cap. It's actually mineral oil in here or some form of synthetic oil. It's almost like baby oil. I went ahead and sniffed it a little bit. I had some mineral oil in my office. I sniffed that first and kind of like did a whiff, and they were very, very similar. You know, put some on my fingers. It's like just like mineral oil is basically what it is.
I'm glad you tried that, not me.
Yeah. So what are we, Lenny, what are we seeing here on this cap? And I know you're fine as far as what's in there.
That's all right.
Yeah.
So what you got here is just basically a ribbon cable that actually acts as the wiring for it, the power wiring. And then the inside, like we mentioned before, or probably later on in the episode, is there's actually another protective material for insulation. It's actually plastic. But if you notice here, if I can actually get it out, the plastic here is more flexible. It's not hardened plastic, because if you were to have a hardened piece of plastic here and it was to crack or anything or harden up, even with the mineral oil, it shouldn't. It loses the insulating capabilities. So they put a plastic in here that's almost like a flexible gel. You know, if you've ever seen, it's like a, I don't know, scaled down version of like silly putty.
Right.
You know, something like that. It's that flexible, but it's filled with oil. It's flexible, so it still has the insulation properties without drying out or cracking.
Right. And the other key purpose of that fluid in there is to prevent arcing within the capacitor. That's really the main reason that it's in here. And again, I did mention earlier that they do make AC caps without fluid in them. We don't have those. This is the style that we happen to have had in our parts room, so we examined it. So like Lenny said, you've got electrode material in there, you got the two terminals, the lead wires, you have the encapsulation, which is a big word, but basically the encapsulation is what you see with your eyes. And that is, you know, it can be either resin or it could be, you know, resin or plastic. It provides protection. And of course you have the inseals and the insulating material inside of the capacitor. And again, all we're doing now is just talking to you about what the materials are of the capacitor. We're not talking about its purpose. That's coming next in terms of AC. Well, they loaded up on us over here, didn't they? Okay. So infinity and beyond, we're back up here on the screen. Looks like transformers. Go ahead, Lenny.
Oh, and Alaskan Assassin 7 is high from Alaska. Oh, there you go. Must be cold up there. I mean, it's cold here in Phoenix today, 41 degrees. So I can only imagine what temp is in Alaska now today.
Oh yeah. Wonder who. Yeah.
Lone Wolf, I think it's lost in space.
So
That's a good guess.
Yeah.
it's not Transformers or Lost in Space.
No.
Yeah. You know, danger, stranger danger. And Infinity and Beyond, what's with the gloves? Is it to hide your fingerprints?
Yeah. Well, we didn't. We kind of didn't know what the liquid was inside of the capacitor, so we didn't want to take any chances. I mean, we practiced PPE, and if I was out there in our depot, and you know, we were actually trying to cut open a cap, I would have PPE on, I would have gloves on, that type of thing. But we found out it's basically just mineral oil in there.
Right.
Yeah.
I wasn't going to take any chances not knowing what's in there.
Yeah.
Definitely wasn't going to sniff it.
Yeah. What's up with the gloves, Claude? Another comment from Grant. Highlander, Lone Wolf, I think I know you on X, the Highlander. To infinity and beyond, at Grant Mobile, it's if the gloves don't fit, he's not guilty. Wow.
You must have quit.
Oh my God. They're bringing in the OJ now.
Hello, Johnny Cochran.
I'm in trouble now. Let me get these things off, man. This is crazy. Let me take these gloves off. I can't get this. No, I'm just kidding.
Yeah.
All right. Field engineer, what does the AC cap do in the circuit?
A multitude of things. I mean, you got anywhere as far as the charge and the voltage. You know, it basically uses it as a charge. You can use them as charging, like this one here. Like, you can use a capacitor battery bank to hold a charge for when batteries are recharging to actually hold the electricity. I mean,
yeah, there's a number of things like
starting your car.
Yeah, so this is the alternating current capacitor, the silver one that we just showed you. Okay, and basically that's at the input of the UPS. So you have your source power coming in, you know, from wherever that is, and the power is dirty. We did a whole podcast on power problems. So the power comes in dirty, there's fluctuations, there might be, you know, transients in there, and what this AC capacitor is going to do is it's going to filter out the dirty power. Essentially, that's what it's doing before it goes into, in a double conversion UPS, before it goes into the rectification process. Okay, that's essentially what its overall purpose is. And again, we have a whole laundry list of things we're going to get to in terms of the purpose of that cap later on. We got another one here. Hello from Indonesia. And then 5 did it hat. I'm not sure if I pronounced that right. What is the best material for making a capacitor? You want to hit that one?
In my opinion, I guess the best core material I think would be ceramic.
Mm-hmm.
It can hold a lot of heat. It's stable and everything. As far as volatility,
Yeah.
it's able to handle a little bit more.
And
So
where do you find those mostly?
mostly in the DC caps.
Okay.
You're gonna find them internally on the DC caps.
Okay.
And everything.
And they're on the PCB board, so
Yeah, most of them are going to be inside of a inside circuit on a board,
Mm-hmm.
or inside of some type of power module, some type of power
You
supply.
might have an example right there.
So yeah.
You have any on here?
No, there's none on here. These are still your electrolytic type of capacitor and everything. Your ceramics or your surface mounts are usually some type of metal
Okay.
side of it, But what I've seen is ceramic are more durable. They last a little bit longer
Mm-hmm.
and everything.
Okay, so we talked a little bit about the materials associated with an AC cap. So now we're going to talk about the materials in a DC cap, because overall they're the same, but there's some key materials in it that are different. Specifically, the fluid. The fluid is actually acid, electrolytic acid, sulfuric acid, in the form of borite. That's basically what they're using inside of a DC cap. It's borite acid. Like I mentioned in the AC cap, we're talking mineral oil. So in that scenario, it's much more dangerous in terms of what you might breathe, the contact with your skin, if there's an explosion or something like that, or if it's leaking. More than likely, it's just leaking. So you want to make sure that you're utilizing the proper PPE. So what's inside of it? You have conductive plates. They could be made out of aluminum or tantalum. You have what we talked about as far as the type of acid, borite. You have lead wires. You can see that there's two terminals on the top of this cap. Those lead wires, the lead wires go into those terminals. They could be either copper or aluminum. And of course, the encapsulation, a little different. This one's a lot heavier than the AC cap. Could be plastic, metal, epoxy. And again, the purpose is to provide protection. But like I said, one of the key differences as far as materials is what's inside the electrolyte, which is straight up acid inside of the electrolytic capacitor. So those are the materials there inside of that. So what are the material differences? Well, a big one is polarity. Polarity between the two. One does not have it, and the other one does. The DC cap is the one that does not have it, because the current can only go one way. Yeah, we're in the AC cap. It goes back and forth.
Right. You have markings for it on the AC, but not on the DC.
Yeah. Actually, I think this one right here this is a DC cap. Yeah.
Yeah,
right
we
there.
had the positive and the negative right.
Yeah.
For it.
Yeah, that's one of the things that you can see immediately on a DC cap, is that it will show you the polarity, how you line them up. When you're installing them, they need to be positioned a certain way. If they're not, it could potentially cause an explosion over time. It could cause the capacitor to leak. And what really happens is the electrolyte inside of the capacitor breaks down. And your operation starts to suffer. The performance of the machine starts to suffer. Okay, we got Lone Wolf, a filter. It's a filter to give a good sine wave. That is correct by the Lone Wolf. To infinity and beyond. Can a UPS operate without capacitors?
I would say a module unit. No. Yeah, I mean, you're going to have some type of capacitor in it if it's component or module. Your modules are going to have the capacitors inside the individual pieces, and your component's going to have caps within the unit itself.
Yeah.
So, but with power going in and out, you're going to need that to store the energy, to release it, and to filter the energy, to take on power spikes, anything like that. That's more components of resistors, fuses, stuff like that.
Right.
When it comes to power spikes, but you need that capacitor to store and dissipate the energy, and to filter it, because if you're getting bad energy or dirty power into it, it's not going to be stable. And with that, there's a tendency of, like you said, breakdown, explosions, component failure, anything like that.
Yeah, and then you see it, from an end user standpoint, he's going to see it in the poor performance of his equipment.
And the equipment's not going to function as to manufacturer standards, let's just say. It's not going to function as properly. It's not going to last as long.
Right.
It's definitely not going to last as long. I mean, probably looking at 50% lifetime cycle of that, if shorter. You may have the rare cases where it may go longer.
Right.
But yeah, you always want to have clean energy. I would say, I think maybe in the 50s, in the 1950s is where, at least in the U.S., we started standardizing electrical grids. We started standardizing, clean power to homes, to buildings, to, stuff like that on the grid itself. And we're still, maybe 20 years behind in as far as updating the grids and everything. Clean energy, going to more of the electric vehicles. We still have tendency. We're still behind on that as far as getting that cleaned up.
Yeah, to your point, we're way behind.
We're way behind. When it comes
to the grid.
But it all comes in with clean power. You have to have that clean power for things to function right.
Right.
Being overseas in the military, we're not as far as behind as what I've seen though. I mean, we have countries out there that are still just they're daisy chaining electrical wires on electrical poles, right? And they're off of transformers and stuff. So we're far behind, but we're not as far behind as what we think with the rest of the world is.
Yeah, well, with the coming, you're speaking of clean energy. Obviously the assault of the electronic vehicle and the tapping into the grid for charging is really what has accelerated the pace of everything, and it's really shown how far behind we are, because a lot of that infrastructure out there is just straight up old.
It is.
Yeah,
it is. And parts like this that still are using mineral oil, still using some type of older type of materials, isn't as efficient. I mean, 20 years ago it's as efficient, but it's not as, if we're still using that, it's not as efficient nowadays and everything. So as things develop, we've got to parts, that's why you see a lot of third-party production now when it comes to parts, even for cars, materials like that. Third parties are finding out more efficient ways to produce a better cap, a long-laster cap, better materials, safer materials, safer for the unit, safer for the user, and not only that, with it being safer and better materials, the longevity is going to increase.
Yeah. So. Good points. All right, let's keep up with these here. No Elvis today? Yes, you might. It sounds like you came on later. Yeah, Elvis is out sick. He had a virus attack him yesterday at work, and we had to get him out of here before it spread. And he's at home right now, resting up. What does that say? 5 did it? I am from India. Can we make capacitors using a superconductor? That's another one right there. Gonna have to get back to in response to that one.
I have no clue when it comes to that one.
Highlander. Hey, gang, kindness is always free from Highlander. Yes, sir, we know. Infinity and beyond. Can a UPS operate with the DC caps but miss the AC caps, and vice versa? Can the UPS operate with just one set of caps? Well, in a double conversion UPS, the answer is no. Okay, because you have what it comes in as AC, it's rectified in a DC. Okay, it's charging it's also providing energy into your batteries, and then through rectification, it's inverted back into AC. So you need both sets of caps. Now, that's a very, very good question. Just popped in my head. Let's talk DC ripple. Okay, so where does DC ripple show up? It shows up in the rectification process.
Yes.
That's where it's showing up. Rectifying it to DC, right? It's already gone through the input filters, through the AC part of it. Now it's getting ready to get into your battery system, and those capacitors are there for the person that asked the question. Those DC caps are there to reduce ripple, eliminate ripple. And what is it? What is ripple?
Ripple is basically
it's not.
It's like a rough edge.
It's not what you were doing in your 20s, right? Okay, it's not that kind. We're not talking about that kind of ripple, by the way.
No, I would say it's more of a rough edge. Think of a stone that you just dug out of the ground or some type of mineral, and it's got rough edges. That's a ripple. When you polish it smooth, and then you see it on a sine, if you see it on a waveform that's coming out on a piece of test equipment, that's what you're seeing is a smooth waveform, that's the ripple being removed
Yeah.
by the DC
So it's
filter.
exactly. So it's actually the voltage and the current
Yes.
being erratic or being inconsistent.
It's inconsistent,
Yeah.
and that smooths it out to
Exactly.
make it cleans it cleans the dirt and makes clean energy.
Right. Okay. So that's pretty interesting. You think about that, you know, how that variability can still be in your system after you've already filtered the source power through the AC caps. So here you are in the middle of the process, basically, and you still have variations that you have that these capacitors are designed to look for and filter out. They call them components. That's what the technical name is. They call them DC components, which happens to be ripple is an example of a DC component that those capacitors strain out. The example I gave Lenny was like a strainer at home. You know, you put a bunch of rocks in there and you're trying to right size your rocks or get all the sand out. You shake that sand, and what's falling through the bottom is what is the capacitor is filtering out that is no good, continuing in the system.
Right.
Easy way to put
basically,
it. Yeah. Let's see. Arturo Lara, can a capacitor malfunction shut down a UPS?
all the time.
Oh yeah.
All the time.
Oh yeah. Well, here's an example. We did a huge job. Fortunately, it was during a maintenance window, so the customer's operation didn't suffer in terms of losing money. This is about 5 years ago. I talked about the whole polarity issue. One of the capacitors in a huge Liebert, it was like a Liebert 600 kVA. There were banks. There were like 6 capacitor banks, similar to what you see right here. We aligned one of the capacitors in there had the wrong polarity. We started up the UPS, and what did you hear?
A pop.
You heard a pop, right? So right away we knew that one of those capacitors, 1 or 2, were not lined up in the proper polarity. So of course we had to dissect that, find the capacitor bank. That added more time. We were still able to turn it around, get the customer up and running in time before his maintenance window closed. But that's an example right there. Yes, that is the answer to your question. A capacitor malfunction can definitely shut down a UPS. Field engineer, we have a service organization come in every 8 years to replace caps. Do you offer this service? Yes, we do. We offer this service. It can be purchased through a normal service contract, service agreement. That can be built in, or it could just be a one-off where we would just come in, do a PM on your unit, and then, of course, change your capacitors. There are date codes on the capacitors. The industry recommendation for AC caps is every 6 to 7 years. That's the end state, but you really should start thinking about doing this from a budgeting standpoint, like around year 5 or 6, because it costs money depending on the size of your machine. It could be thousands and thousands of dollars for the AC and DC cap replacement.
Right. And of course, those prices are still going up.
Yes.
Year.
Yes, that was a great question right there. Okay, let's go ahead and move on. So we were talking about the differences between the two, why the materials are different between the two. We talked about that a little bit. Polarity is a big part of it. Also, the electrolyte inside of the capacitor is a big part of it, allowing the voltage to go back and forth. Then you have the other items inside the UPS because they're used for different functions. All right. There's also configurations. There's like 6 different types of capacitor configurations. We talked about the output filters, which is the DC capacitor bank. That's an example of an output filter. Jesse, if you could put in image number 7, we're actually going to show you 2. We'll show you the output and input, what it looks like inside of a UPS. There's a really good question right there. We'll get to that one after this picture. Okay, you see a UPS technician, and in his hands, he is either removing or installing an AC capacitor bank. You can see that. And then up above him are the DC capacitors. So the output capacitors are up above him. And what that means by output is that the DC capacitors are the output into the rectification process. Step after that is inversion. So like I said, the ones in his hand, those are the input AC caps, and then the ones up above are the DC caps. Another question here, how do you test an electrolytic capacitor?
And you can actually just, like you guys did last week on the last podcast, you can use an ESR meter, or you can use an LCR meter.
Mm-hmm.
An LCR just measures resistance, capacitance, and inductance.
Yeah.
So you can use one of the 2 meters for that, because what it's going to do, it gives it a little bit of jolt of electricity through the capacitor, and then measures what the ohms are coming back out.
Yeah.
And see if it's good or not.
And that's all, that's all technical. So what is that just in layman's terms?
In
What does that mean?
layman's terms is basically, as a kid, if you guys remember taking a 9-volt battery and sticking it to your tongue to see if it's energized, that's what you're doing with the cap. See if it's still good. You're just placing energy to it. It's going to read it back to you to say, okay, I can handle it, or I'm dead. Basically, that's what it's measuring. It's measuring the ESR factor as far as the ohms that can, what can filter, store for capacitance, and also how much it can flow through. And then, so that's the only way I can really tell you, is we put a little jolt of electricity through it from the meter. And then basically it tells you if it can handle it or not.
Okay, so like on this board right here, I see 1, 2, 3. I see 4 electrolyte
Right.
capacitors on there. So say I have like these 2 right here, and you test one, it's good. You test the other one,
It's bad.
It's bad, but they're like linked up. So how?
It can be.
Yeah.
But the thing is, though, is some of them, if you read, if you measure one and it reads good, and they're in series, what they're going to do is they're going to take on the properties of both. So if you have 2 capacitors that are in series with each other, they're going to take on properties of both. So if one has a microfarad reading of, say, 10 microfarads, you're going, or as far as voltages, you're going to read duplicate. If they're in series with each other, say 2 of them, you're going to multiply it basically by 2. If they're not, you'll read the individual ones. So one will test good, one will test bad if they're not together, because if they're together, sometimes they can mask each other just a little bit. But we test each individual one, and the test equipment used is really accurate, and it'll determine, even if it's series, if it's bad or not.
So what are your typical findings, I guess, if you had to Pareto them, the old 80-20 rule, what are you finding the most of?
What I'm finding most of is these type of capacitors last. They really do. It's your surface mount capacitors, your smaller capacitors.
Okay, when you say these type, you're talking about the
electrolytic ones. They last a lot longer. The only time I really see these go bad is if they start to leak. If they start to bubble at the top, they'll have a dome look to it instead of a flat surface. And then the liquid will start actually oozing out. Now, the caveat to that is I've actually measured a lot of those that have the dome look or the leaking, and they're still within factory standards. But the problem is, though, that's with no power applied, or just minimal power applied. Who knows what happens when you actually put full power to them? They could be bad. That's the other thing. Capacitors out of the system with the minimal could be good. They can show good. But once you put full capability to them, full power to them, they might actually turn out bad, or blow, leak, or something like that. So, but 80-20 rule, it's most of the time with these style, they last and they last and they last. It's just a matter of defective material breakdown is what usually causes them to go bad.
Okay, so surface mounts are the ones that you're replacing.
Surface mounts are the ones you're most of, because the materials used in them, they just don't last as long. And that's what I was talking about as far as the development of parts as the years go by. They're getting better and better, and they're lasting longer and longer. And sometimes you can actually upgrade the capacitor. If a capacitor has a certain characteristic to it, you can actually put another characteristic that's better characteristics as far as capability or what it can handle. You can actually put that in, and it will still function because it's meeting the minimum standards, but now you're going above and beyond.
And you're talking capacitance there.
Right, I'm talking about capacitance as far as microfarads and voltages.
Yeah.
If I have something that I have 450 volts flowing through it, or let's say I have 100 volts flowing through it, right, and say 35 microfarads. If I was to go ahead and put a cap in that handles 450 volts and 50 microfarads, that cap's going to last longer because it's able to handle more longer.
I see.
So it'll handle more ripple effects, more bad energy, more power surges or whatever. It'll be able to handle that because it's got better characteristics. So that's the other thing nowadays too, is what can we upgrade to make it better, to make it last longer? not going with what has already been in there from the factory for 20, 30, however long it's been in there, like you said, 6 to 7 years.
Right.
So are you putting something better, or are you just putting the standard, what the OEM recommends? And that's part of all the engineering and the troubleshooting and just back and forth learning what works and what doesn't work.
Okay, let's see. What happens to the phase relationship between voltage and current in a capacitor as the frequency of the AC signal changes? Happens to the phase relationship. It's varied. It varies between the voltage and current in a capacitor as the frequency of the AC signal changes. It's going to vary back and forth. We have this really neat device. It's called a phase rotation meter that each one of our field engineers carries. And one of the things that they do on their PM is they check for proper phase rotation. So in a 3-phase unit. Let's see, manage how to calculate life of a electrolytic capacitor. That is based off hours. And there's a rated number of hours based off a specific load that the UPS is projected to carry. And it will spit out a number of hours that you should get out of the capacitor. But there's a lot of assumptions made there, that you're not having erratic voltages, it's just basically normal operating procedure.
Right. No material defects from the manufacturer.
Yeah.
Is a big one.
Yeah. So that's a big deal. Really, really good questions. And we already talked about the testing of the capacitor. Let's see what else is up there.
Did you do this one?
Gonna skip that one. Okay. Got, let's see. How long do capacitors normally last?
I've seen capacitors last 20, 30 years, depending on how they're being used. Like you said, industry standard on the component level, 6 to 7 years. It all depends. It depends on how much is being used, how many hours, the materials that are inside of it. There's a lot of factors to determine. It's like driving a car. How much are you maintaining it? How much are you taking care of it? Are you neglecting it? Environmental conditions play a big part in the lifespan of any component.
Yeah.
So it all depends on a number of factors, I guess. There's no set determination to determine how they last, so just based on statistics.
Yeah, and it's more preventative maintenance. Like Lenny said, they could last 10, 15 years, but you don't know. So the preventative maintenance, the industry standard is every 7 years, you change out your capacitors. The typical life of a UPS right now is like 12, 13 years. So, it becomes an investment. It becomes a money issue. We tell our customers, when you get to like year 18, you think about all the other components that are inside of a UPS that have not been changed, that are 18 years old, and you're going to spend thousands to change out your capacitors, only to have a failure 3 or 4 months later. This is stuff that I've seen in my time here at Gruber. Let's see, Lone Wolf. I can't remember the name of the movie, but I think the robot's name is Max. Well, let me go ahead and break to you what this is. I don't know if you remember the television series Battlestar Galactica. I'm sure that's ringing a bell with several of you on this podcast right now. Battlestar Galactica with Lorne Greene. He played Commander Adama, and their enemy was the Cylons. There you go. That's a much better image right there than what I showed. That's what they look like right there. These guys lit up and energized themselves with power capacitor. You can see they were already using kind of like a LED screen for their eyes. If you look real close, there's a red pulse signal that was going back and forth. So this is the 1980s. We're talking like 1983, 1984, when this television series was on. Maybe even earlier, because I think
it was earlier.
Yeah, I was still at home. It was in the 70s, actually, the late 70s. Yeah, because I was still at home. I hadn't left home yet. Yeah, so really cool. There's this one person by the name of Theodore House that works here, and he is a sci-fi guy. I think Theodore's like 35 years old, and I go, hey, go look at the thumbnail and let me know if you know what it is. I already knew he was going to know what it is because he's just into it, and sure enough, he knew exactly what this was. He described it to me and a whole bunch of other detail I didn't know. So that's pretty cool. AI self-aware forever. Hello all, I just became self-aware. Another one from AI, self-aware forever. How does a capacitor behave in an AC circuit compared to a DC circuit? And I know the answer since I am AI, but wanted to challenge the team. Okay, you want to take a crack at it? I can say one difference. There's a significant difference between the two circuits when it comes to the capacitor. The AC capacitor allows for and tolerates voltage and current going back and forth. Okay, it can go both ways. And the way it's made, the materials and how it's designed allows for it to be capable of doing that without destroying it. The DC capacitor, on the other hand, is designed differently, and it only can handle the current and voltage going one way because it's in the DC circuit. Okay, so that's a huge difference between the two right there in terms of handling signals. Okay, another one. I think one of the viewers, this is from Field Engineer, I think one of the viewers is a bot who just became sentient. I wonder who that person's talking about. It must be me. What do you think?
Yeah,
Well,
I don't think AI happening in the chat today.
I don't think you're a viewer.
Oh, one of the viewers is a bot who just became sentient. Yeah, I'm not a viewer.
Yeah, the bot just came sentient, and AI self-aware just responded and said correct.
Okay.
Apparently there's AI in our chat.
Yeah, Highlander. Yeah, I remember Battlestar Galactica. I loved it. More to the point, if you're not going to serve as your capacity, just call modular the Highlander. And then self-aware forever, correct at Field Engineer. Okay, got back with me then. Okay, I think I missed one up there. Yeah, right there. Twin Mom 1492. For capacitors, how do they aid in transient response? Want to take that one? I mean, they're sifting out transient responses or transient signals. That's one of their
That's
main
all
purposes.
it's doing. I mean, you have something like a ferrite material that can actually filter out voltages too, like on the back of a TV. I don't know if anybody's old enough to remember these little gray blocks that go back on your power cords that, they're usually about 6 inches from the power source on your TV, on the actual plug into the TV.
Yeah.
And that's what that's doing. That's filtering out voltages for noise reduction, so you don't get feedback. That's another thing, as far as interaction between electronics, you have voltages that can interfere that aren't being filtered, that aren't being streamlined or cleaned.
Right.
So you have that too, like a ferrite material. That's a form of a capacitor too. That ferrite block on a power cable.
Yeah.
So not a lot of people understand. They think a lot of people don't understand what that's there for. But what it is to help voltage bleed over into other items. That's what a capacitor does. Also filters bleed over.
Right.
Keeps frequencies down.
Yeah, remember this was probably 6, 7, 8 weeks ago. We did a podcast on just basic power problems, and just specific to the capacitor. Lenny just stated voltage fluctuation. So if you look at the overall and what the purpose of a capacitor, it eliminates or minimizes voltage fluctuations. It addresses sags and dips. He mentioned noise reduction. You're talking about the static when you turn when you remember the old radios when you would go from channel to channel and you would have to tune it almost in. You're talking. Is that what you're referencing?
Well, yeah, something like that. But I don't like power, like your power cords. If you have power cords like sitting next to a data cable, that power can actually interfere with your data signal. So that ferrite block actually filters. Streamlines that voltage that's going through like a capacitor and filters it out so it's smooth, so it's not interfering with your data cable.
Right.
So you can things like that. It's just odd what we have out there that we just don't think about. That's what it's used for.
Yeah, one thing that you said back, you were talking about the quality of the capacitor, and I started thinking about that a little bit more. You're right. I mean, like anything else, there's different levels of quality. So when I think of high quality, I would want the best cap possible for a data center, with servers being in there,
Right.
but not necessarily for some other type of operation that you can get away with a little bit more electrical noise, if I can say that,
Yeah, I mean, it all depends on what, like you said, it all depends on your operation. It all depends on what's important to you, Everybody has a different value, brings a different value to the table
Right.
when it comes to that, but like data centers, server farms, stuff like that. You definitely want to have more clean energy. You want to have better components to keep it running smoothly.
Yeah. Hey, one other thing before I skip, and I don't want to do this. We put out a video on capacitor replacement on YouTube. It's one that Pete did. We call it Pete's Rants. I think there's like 4 or 5 different videos on there now on our YouTube channel. You can go there and you can watch it. Or, our topic today is capacitors. So Pete does a really good job of, it's like a 5-minute video, easy to watch, does a really good job of walking the audience through a capacitor replacement, why it's important, and that type of thing. So if you get a chance, go there, watch that video, and let us know, give us some feedback, give us some comments, like it, that kind of thing. Okay, here's another one right here. How do we calculate electrolytic capacitor life? Specifically, my question is AC drive capacitor bank. Take a crack at that one.
It's the same thing.
Mm-hmm.
I mean, they're all put together. They'll all individually have a lifespan, but they collectively, it'll just make it go longer because they're all basically sharing the load. They're sharing everything coming in. So it's not necessarily one is taking on more. If one fails, the other one takes over. One fails, the other one takes over. They're all collectively evening it out. They're all taking on this, they should all take on, if they're within series, they should all take on the same voltages and everything coming in. They divide it. They should divide it, but that doesn't necessarily mean it's going to work that way. But individually, they have a rating, and then together, it just increases that rating.
Like batteries.
Yeah, like batteries. If you have a string of batteries, one battery goes bad, then the other ones are going to start failing.
Right.
Same with this. If one is starting to break down, then the other ones start to break down. Not necessarily to mean those are bad. It's just a matter it starts taking on characteristics because one's not handling its portion of it.
Right.
Okay. So to determine life, it's all based on individuals put into a bank.
Okay. Let's see here. AI again, self-aware forever. I wonder who that is. Battlestar Galactica quote, "You cannot play God, then wash your hands of the things you've created." That quote, I don't remember that one. I need to find out who said that. I wonder if that was Commander Adama. Okay. If a unit goes without maintenance for a long period of time, what kind of problems would someone be looking at if they don't take care of the unit? Well, visually, a lot. First thing you do when you walk in is you assess the environment. That will tell you a lot. Before you even put a meter on anything, checking voltages, current, temperature, you can walk into a UPS room and determine whether or not that UPS is actually being taken care of. You find a UPS in a closet with the door closed, there's no AC, you bet your bottom dollar the batteries are probably shot. Okay?
I'm sorry, go ahead.
Yeah, you walk into, well, capture that if it's the same subject because I was getting ready to
yeah, I mean, and then your components are heating up. I mean, capacitors only, just like any other component, capacitors also have a heat tolerance, or a cold tolerance. Sometimes, say something's, cold can cause things to crack too. Not heat causes it to expand to explode, but cold can shrink and crack it also.
Right.
So, normally, typically you won't see that at all, but there's always a possibility.
Yeah.
You
another example would be, a larger unit, say a large 3-phase system. You go do a site visit and the UPS is out in a warehouse with no air conditioning and it's dirty, dusty environment. Now, I haven't checked anything. I haven't put a temp gun on anything. I haven't looked at the event log. I haven't done any of that. I haven't hooked my computer up to it to see how many times it's cycled. None of that. But just those things right there can tell you a lot, that there's probably going to be issues with the UPS. We've even walked into sites where the customer didn't even know the UPS was in bypass. We have, found UPSs in bypass and have had to notify the customer. So yeah, that's before a meter is even on it. That's called sensory deduction. That's what that is right there. AI self-aware. What are some of the, can you scroll that up a little bit, Jesse? Okay. What are some of the best capacitor brands out there? The best. Here we go again.
Best reliability. I mean, it all depends.
Cornell
look here.
Dubler is
Cornell
a pretty good brand.
Dubler is good. Rubicon is really good. Rubicon's a really good brand. You also have a German brand. I can't pronounce it correctly, but it's like Wustarf or something. Not the knife brand, but they're a good German brand. They're compatible with the ones that Chinese and the Asian countries are actually producing everything. But they're actually a good brand for its buck. Rubicon's good. Cornell Dubler is a mass producer of caps, from the micro levels, service mount and stuff, all the way up to the component levels.
And they're manufactured in America. I like that.
They are. They are a little bit more expensive, but yeah, I mean they are manufactured here in the U.S. and they're very reliable. And like I said, they have an assortment of everything that you could possibly find. But those are probably the three brands that I've seen in my experience that are some of the better brands.
Okay, we got one person wrote Panasonic is also a top brand. It's called AI Self-Aware again. It's called 𝐓𝐢𝐦𝐻𝐬. Did I pronounce that right, or 𝐓𝐢𝐬𝐻𝐬?
Sounds right.
Okay. Yeah. And then up before that, the individual that made that comment on Battlestar Galactica was Commander Adama, Admiral Adama, actually. I was corrected on that. All right, we talked about what are the best capacitor brands out there. Okay.
I think that's it.
All right. Great. Man, lots of questions today. Lots of questions. Hey, one other image I want to show, Lenny, is the Snubber Capacitor. We were on capacitor configuration. So here's another type of capacitor. It's used to suppress voltage spikes. And that's image number 11.
And like I was talking before, those little ferrite blocks is like a snubber capacitor. It's actually like that. Now, there's no real electricity flowing through them except for radiant electricity or signals or frequencies going through it. That's actually a snubber capacitor that goes on your power cord sometimes.
Okay. But this particular image here, these are typically found on PCBs. Okay.
Yeah, and
I might have one.
I mean, some people will get them confused with the fuse. So, for example, like these right here, these are snubber capacitors, these brown ones here.
Okay. And this board goes to?
That's an ASY0673. It's a power module.
Okay.
So it's actually a power supply card.
Yeah, for a PowerWare.
Yep.
I think a 9170, if I'm not mistaken.
Yeah, it is.
Yeah. Okay. Yeah. And this one, I don't see any on this one.
You would have something like these.
Yeah.
These gray blocks here. Like I said, typically they get confused when you first look at them. It's a type of a fuse or maybe a resistor.
Right.
But they have various shapes, sizes, colors, textures, materials to them. So, you just got to go with what the marking, what actually is on the board. Hey, this is a capacitor, this is a resistor, or anything like that. But it's funny how I had mentioned that ferrite before, but that's a type of it. So,
and then Jesse, if you could put up image number 9. These are battery bank capacitors we're going to show you. Another configuration. And these capacitors are critical. They regulate the charging and discharging. Very critical. You can see a bank of them right there on a circuit board. So again, we're talking these right here. These aren't on this board, but the same type of capacitor, electrolytic. Yeah.
This one you said 9?
Yeah, right there. That's it. And then one more. Well, we already talked about snubbers. We already got output filters. Okay, we're good. We're good with the pictures. Okay. All right. Well, enough is enough. And what we're going to do now is we're going to transition to some did you knows. And I'm going to start off with the first one.
Okay.
All right. The oldest trees in the world. Does anybody know the name of the oldest trees in the world?
Are they the sequoias?
That's a good guess, but they're number 2.
What about the olives in Italy?
No, they weren't even in the top 5.
What about the Amazon trees? What are those called? I don't even know what they're called.
You guys are going to be totally shocked on this. I was like, what? The oldest trees in the world. These trees are 4,800 years old.
Bamboo?
Mm-mm. No, I want to wait for a few responses.
We'll wait for some guesses. We got them coming in now.
No Googling on this.
Yeah, no cheating.
Bonsai, no. Redwood, no. Redwood's the tallest tree in the world, though.
Oh, here we go. We got a couple more.
Rubber?
They got it. You are correct. AI self-aware. You Googled that.
He definitely had to Google
You
that.
Googled that. There's no way you could have got that. The Great Basin bristlecone pine tree.
I never even heard of that.
Yeah, the Great Basin bristlecone pine tree. What's really cool about that, too, is you know where the Great Basin is.
Mm-mm. Off the top of my head, I cannot remember.
Anybody want to
I've
guess?
heard of it, but I don't remember.
Is that Nevada?
Yeah, yes. It's a national park, actually. Great
Wait, what?
Basin.
There's pine trees in Nevada?
Yeah, Great Basin National Park. That's where that is. It's a fabulous, spectacular place. I've been there. Amazing place, and it's like a huge basin. And of course, you can go up in the mountains, and there's those trees. Of course, I didn't know this until today. I just Googled it, but that's pretty amazing. The bristlecone pine. All right, I got another one for you guys. The longest bridge in the world. The longest bridge. No Googling, please. No Googling.
Okay, we got
I
some
know
other
there's a
ones that
bridge that runs between Louisiana and Mississippi that's about 28 miles long.
It dwarfs that bridge.
Really?
Yes.
And that
Oh.
bridge is out in the swamplands, too.
Yeah.
If you guys have ever crossed it, it's out in the middle of nowhere. It's part of I-10, actually, in the south.
And when you talk of infrastructure, 4 out of the 5 top longest bridges are in this country. 4 out of the 5
Longest?
longest bridges are in this country.
Is it Argentina?
No.
Oh, don't tell me.
London Bridge, you little bee. I can't believe you.
AI software.
Did I say little bee? I'm sorry.
Well, little B.
Hey, AI self-aware. I'm sorry. I'm sorry. Totally sorry on that
Little B
one.
stands for bridge, right?
Yeah. London Bridge, is that the one? Is that the actually London Bridge or the one in Arizona?
I don't know. No, the London Bridge is short. And then the Golden Gate. No, it's a beautiful bridge, but
Is there
this bridge dwarfs
Is
it.
it the bridge that connects Washington to Oregon? The
Astoria?
Astoria?
No,
No.
Wait, is it considered a bridge? What goes out to the Florida Keys?
that's yes, that is. That's a 7-mile bridge. This
Right.
bridge dwarfs it. You guys, this is like unbelievable. I can't believe they can make something like this. You cannot of your breath in that bridge. AI self-aware, that's got to be in India. No, it's not in India. Jesse, I'm surprised that you don't know this. I'm surprised that you don't know which country.
I mean, I do, and I just don't want to say it.
Yeah.
Is what, China?
Yeah, it's China.
It's always China.
Yeah.
Everything's always China.
Well,
Okay,
the-
four out of the 5 longest bridges in the world are in China. The second longest bridge in the world is in Taiwan. The longest bridge in the world, are you ready for it?
Great Wall of China.
Are you ready for it? The longest one, 102 miles.
What?
Wow.
102 miles. The bridge in Taiwan is 97 miles long.
Wow.
That's what I said. It's like, who wants to be? I mean, I wouldn't. I mean, that's like,
That's a real long bridge.
yeah, that's a really, really long bridge.
No land in sight.
Now I didn't check that. You know, it might be connected like the Florida Keys
Right.
are. You know, connected between
Right.
the Keys. That's a 7-mile long bridge.
Right.
You know, so it might be. I'm pretty sure it's like connected that way.
Mhm.
But still, though, you're going over water.
Right.
And then you're going over water
Mhm.
again. You're going over water for 102 miles.
Mhm.
I mean, think of Flagstaff. That's like driving to Flagstaff, right? So, all right, Lenny, what do you have?
Okay, this is for up your alley, so I know you're a big Star Trek fan.
Mm-hmm.
The first Star Trek comic book sold at an auction for what record-breaking price?
$1 million.
Not even close.
Higher?
A lot lower. A
lot lower.
Per comic book?
You're right. Yep.
Star Trek, the original series.
The original Star Trek comic
Theodore,
book.
if you're on, Theodore, if you're on, I know you know this. He's a Star Trek buff. He would know this. Yeah.
Right.
Okay,
Yeah.
so like,
It's a lot lower than I thought. I thought for sure, million, 6, 7 figures easily. We're into it's in 5 figures. Well, I'll just give you this 5 figures.
okay, let's see what comes
50
back on this
grand.
one.
Very close.
All right, AI Self-Aware Forever actually gave the name of the bridge in China, the 𝐓𝐢𝐦𝐞 𝐒𝐭𝐚𝐦𝐩𝐬 Bridge, 102.4 miles. Okay, AI Self-Aware, 10 Gs. Is that correct?
No, a little bit higher. 50K is pretty close.
Ramp Mobile, 15 Gs.
$50K and $1.
Are the prices right?
It's not the price is right.
No.
So I don't see anything else coming in. I mean, how much higher are we talking? 70K?
No, $46,500
For a comic book?
for the original Star Trek comic book. That was the record-breaking sale
With
for
Kathleen,
that.
with William Shatner, the animated.
I'm not sure who is that William Shatner in the comic book, but
No. I mean his animated image.
right.
Yeah.
Yeah, 46,500. That's it. You would think you would think maybe 6 figures, 7 figures, but no, only 46,500.
Do you happen to know?
Surprisingly.
Do you happen to know if that owner still owns it, or
Don't
did
know.
it resell?
Don't know. They probably sat on it for a while and resold it, but that was the
Hey, whoever
record-breaking sign.
whoever this AI guy is that keeps typing all the right answers. Okay, I'm like, I'm gonna find out who you are.
It's AI. Yeah.
Cough. Elvis cough. That's
Yeah,
my
it's
guess.
Elvis at home Googling.
That's
Probably
my guess.
is.
Yeah.
This guy knows. AI knows everything.
Mm-hmm.
Yeah. So the next one, I actually had a friend of mine tell me this one, but Tony Gwynn, famous baseball player, Hall of Famer, 20-year career with the San Diego Padres. Actually played at San Diego State, coached at San Diego State too. He actually has something in college that he did in college. He did something. He achieved a stat in college that outperforms a stat that he did while he was a Major League Baseball player. What I can't really give it away, but what does he have the most of in college than he had as a Major League Baseball player?
And you're talking a baseball stat.
Well, it's a basketball stat and a baseball stat combined.
Okay.
He had more, and he had more of a stat in basketball in college than he had as a stat as a Major League Baseball player in 20 years, instead of 4 years at college.
And the stat is common to both as far as the name.
Yeah, it's a common stat for both. I mean, they're not the same stat, but they're a common stat name. Yeah.
Okay.
Grant Mobile says steals.
No, not steals.
That's a good guess.
That is a good guess.
That's
Is
a
it
really
assist?
good guess.
That is a really good guess.
Is it assist?
Assist is for basketball, yes.
There's assists in baseball too. Outfield assists.
Right, but typically we don't really deal a lot with it. It's not a common stat. It's not a common stat. This is a very common stat.
Was it okay? Baseball and basketball.
Mhm.
Was it his percentage?
No, not his percentage.
Right here, we got 2 that say wins.
No, because you get more wins in 20-year career than you would in 4 years at basketball.
Mm-hmm.
I was amazed by it,
And it's common.
and it's common.
Why isn't this coming to me?
Walks.
No, close, very close.
Bunts.
No, not bunts.
Hmm.
You guys ready?
Yeah.
Okay. Tony Gwynn had 590 assists in college playing basketball for San Diego State. His 20-year Major League Baseball career, he had 434 strikeouts. He had more assists in playing college basketball than the times he struck out in a 20-year career.
Wow.
Right?
Mm-hmm.
Right? One of the most unheralded, unsung hitters of all time.
Mm-hmm.
Yeah.
Amazing.
That is amazing.
Wow. Pretty good.
And I got one more. I'll throw this one
let's
out
go
there.
for it.
How many undrafted players are in an NFL Hall of Fame that were not drafted by an NFL team.
Okay.
They could have been drafted by another league, but they weren't drafted by an
Ask you
NFL
another
team.
question first. How many Hall of Famers are there? In the Hall?
There are I think there's 278 Hall of Famers as of right now. And 7% of them are undrafted. Well, a little bit more than 7%, I'm sorry.
Okay, so you gave me the answer. Yeah, you said 7% are undrafted in the Hall. And who are some of these names?
Let's see. Warren Moon
Ooh.
was undrafted out of Washington. Kurt Warner, local Arizona hero, undrafted. He actually signed with the Packers, but he went undrafted. Steve Young went undrafted from the NFL. He was drafted by the USFL in the mid '80s. Played 3 years with the LA Express, but was not drafted by an NFL team.
Wasn't Jim Kelly kind of the same?
Jim Kelly. There were 5 players from the USFL that weren't drafted by the NFL that became Hall of Famers. Reggie White,
Herschel Walker?
Steve Young. Herschel Walker wasn't. Sam Mills,
Wow.
Pat Zimmerman, and I can't remember the 5th one off the top of my head, but Reggie White was not drafted by the NFL. But there's 22 undrafted NFL players in the Hall of Fame, including Lou Groza, who's the most famous kicker of all time, as far as a place kicker. And what's funny about him, he actually made it a Hall of Fame as a kicker, but he played 21 years as a left tackle for the Cleveland Browns and their place kicker.
Wow.
Right.
So Warren Moon and Steve Young. Are there any other quarterbacks in it?
Kurt Warner.
And Kurt Warner.
That's it.
That's amazing.
That is it. Yeah.
Wow. Okay.
23 is pretty close.
Yeah, that is. All right. Well, we all struck out on our guesses. True. That's from the AI guy again. Kim Estrie. Oh, I thought they were the same thing, but that's impressive. She's talking about the baseball. And then 23, what was, oh man, that's a good guess.
That's a good guess.
Well, we got this one from AI as well that's saying, they must have Googled it. They're saying there are 371 members.
Okay. 371 folks, and all the people that have played professional football, there's only 371 in the Hall.
Right. And the modern day draft didn't start till 1936.
That's a place I've been to. That is an epic place, especially where they have the golden bus that you see them get every year, the ones that go in. They have one room where it's just the lighting in there is amazing, and they have all these golden busts in there. And it's, I took my oldest son there, and I just got goosebumps, man, when I walked in there. It was like, it just was just amazing.
It's your childhood.
Yeah.
I mean, if you're into that, you see that as a child, you dream of that as a child. Some kids do, and just to see your heroes more idolized.
You want to guess? You want to guess?
Permanently.
You want to guess what bust I had to see first? The bust that I was looking for in there that I had to see first. Now remember, I played receiver. Okay.
Jerry Rice.
Well, no, it wasn't a receiver, but I played receiver. So I'll give you a hint. It was a quarterback.
Quarterback that you had to see?
That I just had to see. I was like, I wanted to see this guy's bust. He's still living. He's still alive.
Roger Staubach.
Nope. Never won a Super Bowl.
Never won a Super Bowl would be Dan Marino.
Dan Marino. Dan the man.
Right.
Yeah.
5,000 yards, 48 touchdowns in
growing
1984.
I remember growing up, and when I was playing, it's like, man, I would have loved to have been a receiver for him. I mean, man, God, that guy was like just pinpoint right on the numbers. I mean, just amazing. Amazing. Yeah. All right. Well, I think that's going to do it. You got anything else?
No, I got nothing else today.
How about the production? How about the production crew? You guys got anything?
I mean, did you see these last ones from AI?
Okay. You can't find me. I live in Meta World.
Yeah, he he lives in the meta world. When you said you were trying to kind of find out who he was.
Okay. I can't Google it when I'm AI. I am Google. Who is this guy?
I have no
Who
idea.
is this guy? Is that the guy I called a little bee?
Yes.
Okay. And then the last one, Google is my neighbors upstairs in the AI universe. Okay, I'm going to find out. I'm going to get with Jesse and Aaron back here after the show.
Yeah, we'll hunt
And
it
we're going to
down.
find out who you are. All right. Well, thank you for watching. And Lenny, thank you for coming on again, subbing for Elvis.
Thanks for
Elvis,
having
get
me.
better. We thank all of our YouTube subscribers, and we'll see you next week.
Happy New Year to everybody.